Hi, I'm just going to run through some basics for Flowcode, give you an idea of what it is that we can actually do with it. Here I've got a program that I've already built. This one took about 2 hours to develop, I'm guessing, but could be inputted now I know what I'm doing in probably about 20 minutes, something along those lines. Now, I'm just going to give you a quick demonstration and then I'm going to take you through the basics of Flowcode. It's not the most comprehensive programming language in the world. There are bits missing, but it allows you to add in C code if you want to do some extras, so it can be quite versatile in that frame. But it is very, very simple, and that's the massive advantage. There's not a great deal of programming to learn, so when we're looking at BTEC Extended Diploma learners who may be more mechanically biased and not so interested in microprocessor programming, then this can be quite an advantageous tool. The other advantage is that not only can we output to something like an Arduino or a PIC chip for the embedded systems, but we can also use this system to program PLCs. Okay, so just a quick demonstration then. If I hit play, what I have here is a 2D dashboard panel, and that's got all of my components put in it. Now what I've done with this program is I've keyed it to actually say a few words, a few things. This is based on something I'm developing for World Skills, so we will hopefully be using this out in Shanghai or something very, very similar to this. Okay, so I'm just going to hit play, and the first thing you'll notice is it says World Skills Shanghai 2021. That's because it asks for that to be displayed for 3 to 5 seconds. And then all the other words and things that are on here are things that are asked for in the particular brief. So we'll start off with, I've got a little rotary potentiometer up at the top here. Now this potentiometer is just to simulate an input from a battery. So as the battery voltage goes down, the percentage of battery will go down, and this is done in a very simplistic manner at the moment. It doesn't take account of the fact that the battery is 0 volts, flat when it's sort of lost 20% of its voltage. It takes account of the fact that it goes down to 0. So if I just rotate this dial, we can see that the battery is actually there between 99% and 0%. Okay. The system active and ready is something that has to be displayed at all times when it's switched on, so that's there. And then we have stabilizers, which are to go on a crane. Either active or inactive is the message depending on where they are. And the way I've done this is we have a set point and a calibrate point, and once it reaches that calibrate point, which we can do on these 4 buttons here, we can set it so that as the stabilizers come down, there is a point where they change to be active from inactive, and when they go back up. And I've done that with a very simple count. So every time the button is displayed, it goes through. The same with a boom angle. So we need to know how many degrees per second or per delay time in this program the boom angle moves, and that's not set up at the moment because we don't know, we've not built one, and it will track the boom angle up and down. Okay, so I've keyed this one in a slightly different way. Instead of just using one switch for one operation, I've actually built it so it's 4 switches, and we type in a bit code. So what we're going to do is we're using 4 bits here, which is 0000 at the moment, and every time I switch one on, I'm going to count up. So I'll do the count in decimal rather than binary. So 1 is forward, 2 is reverse, 3 is left, 4 is right, 5 gives us clockwise rotation, 6 gives us counterclockwise rotation, 7 is actually starting to count up on the boom. So we've now got stabilizers active, sorry, the stabilizer, not the boom. We've got stabilizers active. And this will now count down, and it should go inactive in a second. Might take a little while because we've had it running as active. There we go, inactive. 9 starts to increase the boom angle, so it's now counting the boom angle up. we've stalled. There we go. 10, we'll count the boom angle back down. 11 then resets the stabilizer, the boom angle to 0 degrees, no matter what the input. That's our calibration setting. And finally 8 would reset the stabilizers to inactive. Now obviously electronically speaking, we're not actually flipping switches. These are just input lines that go active or inactive to the actual system. So that's an example, and how this simply runs is I set up by initializing the LCD panel. We're going to go through that in a moment. Then I change the foreground color. The foreground color is what color the text will be, or the writing. Then I've told it to print world skills in a predefined location, print Shanghai in a location, print 2021 in a location. Then I've asked it to draw a rectangle and delay for 1 second, and basically these 4 rectangles come in 1, 2, 3, 4 for 4 seconds, because remember I said that you had to do it in 3 to 5 second sets. That's my parameters. Then I change the foreground color and draw another rectangle, wait a second, change the foreground color, draw another rectangle, wait a second, and finally the fourth, and draw the fourth rectangle and wait for a second. And then I go into a loop. So the loop, this will only run once in any time we start the program, and then the loop will run forever. So the first thing I've done is clear the display. The second thing is draw the rectangles back in, and that might sound daft, but that's necessary because of the way that things are done. And following this, I have set up some inputs. Now those inputs relate to these switches, and we will go through how I've connected those in a moment. But the input is pretty simple, and I'm just going to open one up, and eventually it will come up. There we go. And all I've said is port B on the single bit of bit 2 is connected to a variable called B2. Now the variable is something I've set up in I set up a predefined list of these variables. So B2, 3, 4 and 5 are all variables that store the current situation of the switches. I've set one up called voltage and one called battery. The voltage one is used to read the voltage from the battery, and then I've done a little calculation to put in the percentage value of the battery. And I've done the same with boom count, port count and stabilizer count. Those are just literally when a switch combination is active, it increases and decreases later. So this is a simple way of setting up the variables for that. Calculation then I've put in, which is port count equals 0. Now port count is giving me a decimal count of the value of these 4 switches. So each cycle I need to reset it to 0, otherwise it would have just counted up each time. I've set the background color to black, which is 10, 10, 10. I'll show you how that works a bit later. And then we go into a decision. Now the decision is simple. Is B2 equal to 1? If it is, we increase port count by 1, because that bit there is worth 1, and that's the one connected to B2. The second one is B3, which is connected to this, port B3. Is the port count, that's the decimal value of 2, so therefore I add 2 to port count. The same for the 4 position, and the same for the 8. So what I've effectively done is encoded these 4 into a decimal number. Okay, put that in port count and kept it there. So then I've changed the foreground color. So again, I've changed the text color. In this case, it would be to blue. And then I've got a set of decisions. If port count equals 1, then print forward in that location. If it equals 2, print reverse in the same location. If it equals 3, print left in a slightly different location, because left's a different amount of words to forward and letters to forward and reverse. If it equals 4, right. And then I've changed the color again, because now I'm looking at the clockwise and anti-clockwise rotation, which I've got a color assigned in the brief. And if it equals 5, then I've put that in that position, clockwise rotation, and a different position slightly for counterclockwise rotation. And then I've got this decision. Now this decision leads to a calculation, and if it equals 7, then the stabilizer count is going up, so I add 1 for each duration that it's doing that, and 8, then I deduct 1. Similarly, port count equals 9, and so I'm going to increase the boom count by 1, and if it equals 10, then I'm going to deduct by 1. Port count 11, that's going to put the boom count to 0, so that's our reset, and the stabilizer reset is on if it equals 12. So now all I'm doing is I'm changing the foreground color to green. I'm printing system active and ready, which is there at all times. I'm printing boom angle because that's green also, and that will be down at the bottom here at all time, and degrees, leaving a gap so I can put the number in. And then this time I'm not printing, I'm printing a number, and the number comes from the variable boom count in that location. This time I'm setting the foreground color to red, and I'm making a decision here. Are the stabilizers inactive or are the stabilizers active? Now, if I just move this across out the way a little bit, you can see that they're exactly the same statement and the same position, the same font size, and all I've done is it greater than 5? Now we can change that number to greater than 10, greater than 20, whatever it is we want. We're not sure until we've built and tested it, but that will set the distance that the stabilizers can travel before they change from inactive to active. Then I'm reading a voltage from the potentiometer, get voltage. I'm taking that and saying that the variable battery is equal to the variable voltage times 20, because that's a 0 to 5 volt signal that I'm reading in. Then I'm going to set the foreground color, and in this case I've got red and green mixed together, so it's yellow. And I'm printing battery in yellow, then the number for the battery in yellow, print percentage afterwards, so it says %, and then I'm delaying for 200 milliseconds. Now the delays on this software are a little bit awkward. You can see on the simulator that it flashed. Now it doesn't always do that when it's when you do it in reality, because 200 milliseconds is about 50 hertz and it's inconceivable to your eyes, so it's okay to flash it around that. But I found 200 milliseconds tends to work best for most panels, not all. Okay, so what I'm going to do now is I'm just going to start a completely new project, and we're going to take you through how I would set all that up. I'm just going to save that. Now, when we're setting up a project, the first thing we need to know is what is it we're using. Now, I went for embedded. You could have opened the other type of project, which would allow you to work with PLCs. The restriction you're going to have on playing with this at home, this is a full working version, but you're going to be restricted to a free version which only has 20 blocks. It's okay for practice, it's great, the students can use it at home for practice, but you can only do small things at a time. You can't put a big program together, but it's still good to be able to practice to do those 1 or 2 things at a time. So we're going to have a look at something that I could do. Now, I'm actually on this one going to select Arduino, and it's an Arduino PDIP. I know it's a PDIP because it's not surface mount, it's a full chip. So if you have the surface mount version that you wish to program to, then you need the SMD selected, but mostly it's PDIP. We've got the options here of pretty much all the Arduino family, all the way down. We can also, if we prefer, select a PIC chip, so something along the lines of the 24FV32 series. We've got the 8-bit versions. Some of you might know that from people chipping and playing with the PlayStation original, and we've also got the 32-bit versions here. We've got a selection of AVRs. We can use it to program Raspberry Pis, but for me, mostly what I use is the Arduino. There's also a set of free targets. Now, the free targets are standard things that are there no matter what you do. So it might be the Microchip PIC kit or 4-pin demo board. MIACs are Flowcode's, or Matrix rather's, version of PLCs. There's Formula All Code, which is a kit you can buy from Matrix, which is to make little buggies and program them to run. You've got the Atmega 328P, that's actually the chip that's in an Arduino Uno, and I could have selected Arduino Uno R3PDIP from this list as well. You may have to because you're using a free version, but I'm going to keep with the Arduino version for now. And we open up our nice little starting point, and all we're going to do is we're just going to have a look at the different inputs and outputs that are available, and I'm going to use things that I know are on the free version so that you can copy this if you wish to. So first of all, we have a blank 2D dashboard panel. So I'm going to go up to displays, and I'm going to select from that a generic 16 by 2. That's the cheapest, most common, easy one to do. You can buy a panel that connects to an Uno with one of these displays on for around about £5. Yeah, they're available from a lot of companies. Velleman, a famous kit maker, of course, is one of those examples. Maplins do a version, Robot Shop does a version. There are all sorts available. So I happen to know that the connection for all of those kits is exactly the same, and we need to change these ever so slightly. And the register select goes to port B0. Now there's two ways of doing this. I can change it to port B0 up here, or I can click on this one and I can find port B1 down here, for example, and just click on the actual pin and that will change it. And then data 0 to 4 is on port D4 to 7, so port D4, port D5, which is the one that's always in a funny place, port D6, and port D7. Oh, I've put it on B6. So we'll try that again. Port D7, and I'll change that to port D6. Okay. So that would be the setup for this type of panel if you were to buy the 16 by 2 with buttons on Shield. So that would be one that you'd probably start with. You might have the E-block system to use. Okay, and the second thing I'm going to do then is I'm just going to put in a simple couple of buttons just so I can show you how this works. So the first one I'm going to put in is just a toggle switch, so it's just simply an on or off switch. I'm going to pop it just to the left hand side, and then I'm going to put in another input which will be a rotary switch. And the reason that I've put these in is these are sort of common components. There are others you can play with, but we need to know what we can do with them. Okay, so we'll just put that to one side for a moment. When I say we'll put it to one side for a moment, that should be on AN0 for an Arduino Uno. You could use AN1. They're both analog inputs on an Uno, but they're the only ones. And on this one, this is now on A0, so that's going to conflict because it's the same one. So I'm going to use a port that I know isn't used, so I'm going to put it on C0. Okay, so that now is the active line for C0, and that's the active line for A0. Okay, so first of all we have a few things up here. This is an input, and if I put in an input block, it asks me to read an input from a digital switch. Now this is only a digital input, not an analog input. It doesn't work for those, so we're only going to be able to read bits, so it's either going to be a 1 or a 0. You've got a few options. You can set it to, for example, port C, which is what this one was, and I could say single bit and it's on port C0. I can also use the entire port, so it would read the entire of port C, but I would need to mask out the bits that weren't being used, because otherwise I could get all sorts of false readings. So that's nice and easy. What we need is a variable, and we don't have any, so it needs to read in and store that information in a place. So the way we would do that is we go up to View and Project Explorer, and on this side here I can now add new. I could have done it, incidentally, exactly the same way from within that, so I'm going to just put hello. Okay, now we've got several different types of settings here. A bool is either true or false. It's either on or it's off. That tends to work well with the inputs. A number from 0 to 255 can be read. An integer, which is obviously a real number, can be read. And then we don't worry about these ones too much. The U integer is just pretty much the same. It's just shifted from 0 onwards instead of sitting either side of 0. So you can't have any negative numbers. A long number, which uses up 2 bytes instead of 1 either side, and a U long, which also again goes from 0 up, so it gives you twice as many numbers in the positive range but none in the negative range. We can read a string. The default size for the string is 20, and floating point. Now floating point tends to be the one that you use when you come to analog inputs, and an object handle I don't tend to use at all. I've not found a use for that one yet. But we're going to create a variable called hello, and we're going to say it's either a 1 or a 0. The other way I could have done that is to open up the input, click on variables, and just add new, and I could put world, and again we could have it as a set of variables. Now all I need to do to put whichever variable I want into this port B is simply double click on hello. It always puts a 0 after the end. You need to delete it. Okay, so nice and easily we've got port B hello. Outputs, this would output a digital pin, so again I could read the state from the input of port B0 and then mimic that output on one or several, if I wish to, different output ports. We're not actually going to do that today. We've got a delay. The delay is set up in whole numbers. You can't use any decimal points, but what you can do is you can specify seconds, milliseconds or microseconds. So it might be 200 milliseconds. 200 seconds would be one heck of a delay, but you can do it if you wish to, and you can call it whatever you want. You can add a description, change its name, whatever, but I just tend to leave them as delay. So now it's 200 milliseconds. We have decisions here, so we can set up decisions quite simply. If something equals 1, so I'm going to say if hello equals 1, so if that switch is on positive, yeah. So if hello, and then we just type in what you would type in on Excel, etc. So if hello equals 1, so that will now say if hello is 0, it continues straight down on the program. If hello equals 1, it will go this way. We could have done that with a switch as well. Okay, so the switch is pretty much the same, but I would have to set it up in a slightly different way. So in this case, I would bring up the screen by double clicking on it, and if switch on port C, and this time I have to type .0, and that would simply, instead of making it a decision and requiring an input, it would simply just read the state of the switch. So if you want to use inputs as a switch, and one switch is controlling one message, this is the easy way to do it. But if you want to do it so that you have got multiple combinations on the switches, like I did on the previous program and used a bit encoding, then you would have to use a decision. So what we now can come to is a couple of other things. Connection point we don't worry about, and jump to connection points. So these are what we used to call go subroutines back in the day when I learned programming. So if I wanted to jump from one point, so I could, for example, decide that if we go to hello, I'm going to jump to connection point A, and connection point A could be a completely separate program that runs round and then returns back to here or back to somewhere else. Okay. Don't tend to use that in Flowcode very often, but it is an option. We have a while one loop, as they like to call them. Now a while one loop is, it will loop around the program forever until it's stopped or turned off. So as soon as you get into a loop, then it does. So the main body of your program is normally contained within that particular set of characters. We have a macro, and we can use macros by simply inserting one and clicking on it, and it will come up with this, but we would have to add a new macro here. We'd actually have to define all the macro, etc. But for components, because we put them in the 2D panel, we don't need to do that. We use, instead of just a macro, we use a component macro. So if I open this up, we've got 3 different types of components here, and whatever's on here, we get all of the options up here. So for the toggle switch, I can read its state, and it will tell me whether it's a 1 or a 0, and I can wait until it's high, and I can use it as an interrupt when it goes high, or an interrupt when it goes low. So those are pretty much the only options for a simple toggle switch. We've got a little bit more on a potentiometer, so we could get the average if we wanted to. So that would read into, if I did it, a variable that I'd set up as an average. So world, for example, could be my variable there. I can do the same with an average integer. I can also read the byte value of it, so I can take an analog input and turn it into a digital byte. I can get the numeric value of it, so I can take an analog input and get the numeric. I can get a string from it. The one I tend to use most is get voltage, which if I'm reading a battery voltage, then I can read in a 5-volt battery and it reads 4.7, so I know it's close to being fully charged, for example. We can get the raw average byte and the raw average integer, which aren't very much use. We can disable the raw and we can enable the raw, and we can also take a raw sample byte and a raw integer. So those pretty much double up on what these are. It's just a raw value as opposed to a digital value. And then on the LCD, we have all the commands that we can use with the LCD. So for example, I can clear the LCD, which is quite simply, it just clears it off completely. We can clear a particular line of the LCD. We can input a particular command or instruction. We can move the cursor, and that usually gives us an XY value for moving the cursor. So for example, 0 is the top line and 1 is the second line on a 16-bit, and then for the Y, it's simply how many characters to the right that I want to shift it. So if I put in 1, 3, then it would shift it down to this line and 3 across. We can print the ASCII code that's coming in from a keypad. We can print a formatted number, which has to be a U-long or a bool, so we can format that number depending on the bool status. We can print a number, so if in our registers or variables that we set up we had a number read in from somewhere, we quite simply print it. We can print a string. Now a string is a particular expression, and we have to put it in inverted commas. Whatever it is, we can write anything we like, but it has to be in inverted commas. RAM write is we need to get a particular string from memory. We can send out the raw data. We can remap a character, so we can change it ever so slightly. Not terribly of use. We can make the display scroll, so we could scroll it to the left and then back to the right and then left and right by using a couple of these. And LCD start, I showed you on my program initialize. That's because initialize is required for graphical displays, whereas for a simple LCD such as this, it is just a start. Okay, so the next bit that we can look at then is I can put in a simulation macro. This simulates certain things. They take a bit of time and effort to set up, so probably not something you're going to do at a beginning state. So the simulation, for example, I can go into, so I can get sample bits, get a speed, I can set channel and properties, and those would all relate to different functions that we could actually get off the potentiometer. So we don't use it terribly often on the simple stuff. Then we can put in an interrupt, so we can put in a standard interrupt, so it's enabled by, for example, this switch. So the program will continue to cycle until this switch interrupts it, and bang, it would do something based on how we've set it up. So what's the interrupt? We can enable it, interrupt on, so port C for example, or we could set it up to interrupt on a timer or on the receiver from the UART. Okay, there's also a custom option, but I can't say I've ever used that. The next bit that we can have then after that is a calculation, and a calculation is usually something that we perform on the variables. So we could have, for example, hello equals hello plus world minus 12, and if I really wanted to, I could then have a multiplying factor, so I might be looking for a percentage here or some number, so I can multiply it by 212, and that calculation would be quite happy with that. So it's any kind of calculation that you could do, but usually we have a variable that stores the answer and some variables that have the information. So x equals y plus z minus 12 times 212, same sort of thing. And then we have a comment, and you can just simply insert comments wherever you like, so that you can talk about what you've done or follow yourself through the program. Now that's quite a useful one in a teaching environment, because you could develop a program and insert comments to explain what's being done. Okay, so I'm actually going to delete this entire program because what I've just put in is a random load of rubbish, and I'm just going to develop a small quick program to take you through. And what I'm going to do is I'm going to say straight away call component macro, open that up. Do apologise for my slow old laptop. I believe I'm running with 8 gig of RAM and it's this slow. And I'm going to print string, and I'm going to print, oh, tell you what I might have to do first. I might want to start the actual LCD. Now that in C program could be 20-30 lines of code, and it's a simple start on this. Then I'm going to call component macro, and I'm going to just simply go print string hello, and oh, I forgot the inverted commas, it does tell you. And what did I say to everybody? Must have it. So I'm just going to say print hello. I'm going to hit play and see what happens on that, and I've got a simple hello here. So I now know that hello is printed right in that corner. What if I want it in the center? Well, it's 1, 2, 3, 4, 5 characters long. The whole thing is 16, so as near to the center as I'm going to be able to get is going to be 5 across. So I'm just going to put in a new macro, and I'm going to ask the cursor to go x 5 y. Come on. Sometimes it's easier to hit tab, by the way. That just moves from one box to the next much quicker sometimes. And I'm going to have the y byte as 0. And if we hit play, I've now moved that to the center. Okay, so quite simple, and that would stay up absolutely permanently throughout the entire program time now. So I'm now going to drop in a loop, and I'm going to use a switch, which is this switch here, and I'm going to ask it to, if port C0 is equal to 1, so I'm going to say read the state of port C0, and if it's equal to 1, I'm going to print world below. If not, I'm going to leave it with just hello. So I'm going to put in a component macro, which will drop to there, but I can simply move it to there, and I'm going to put in a second one to go with it. Now the first one I am going to do quite simply is LCD cursor, there we are, and I'm going to put that on the X byte of line 1, so the next line down, and on the Y byte I am going to put it also at position 5 because world is the same amount of letters. Okay, and I'm now going to say, when this one opens up, print string world, and hit OK. Okay, so if the switch is active, it should run around this loop. If it isn't, it should run around this loop. Okay, so I've got a slight problem now, that if I clear it, I'm only going to get hello once, so clearing the entire section is going to be a problem. So the only way I can overcome that is to pop this within the string, so it goes round and round and round. Okay, so I'm going to click on the bottom here, put in a component macro that is clear LCD. So LCD clear, and then I'm going to put in a delay, but of course I want the delay before I want to clear the LCD, and then quite simply 200 milliseconds. Okay, so if I hit play on that now, the simulator will say hello, and it still says hello, but it should add in the word world, which it doesn't seem to be doing. So what have I done wrong? Okay, so switch port C0 equals 1, so let's just have a quick look at my switch parameters. Port C0 active high, so that should be correct. LCD start. I'm just going to try taking out the cursor module. I might have done that wrong perhaps somewhere. So, yes, I have. I've put the numbers upside down. So it should be 5 on the X and 1 on Y. Come on. So what I actually told it to do was do it on the 5th line, and there's only 2 lines displaying. So that should fix that quite simply. So hello, and then world. As soon as I turn the switch off. So quite simply we're making the decision that way. That's the nice easy way to do this program. The other way we could have done it is by using a decision here in this section. So what I'm actually going to do now is just modify this program to do that. So firstly I would need to read an input, and I'm going to put the input there, and I'm going to set that up to say port C0 single bit 0 returns to the variable world, delete the 0 off it. Okay, so now I'm going to delete, no, I'll leave it for a second because otherwise I'll have to put it back in. So now I'm going to put a decision in, that's a delay. Now I'm going to put a decision in, and if port C0, sorry, so if world, which is port C0, equals 1, then we're going to take it down the positive ramp. If it doesn't equal 1, then it's going to just continue. So I'm going to drop this in here and this in here, because it would be the same commands to print in the same place. Now this time then I'm reading port C0 and I'm just looking for commands. So if I switch that on as well, I've still got the same message hello, and I've still got world. So there are 2 completely different ways of cracking the same simple egg. It's a nice one for you to practice with and just see if you can get everything set up, and the next couple of videos will go through something a little bit more complicated.